Hello again. In this series of videos, I've been showing how to use a variety of different calculators to plan a leg in a cross-country flight. This video will be showing how to use the CR-3 calculator, which is obviously a manual calculator, an E6B type of calculator, and we'll be showing how to do all of the figures that we need to calculate using this. This one's a little bit different, and I've not as much experience on it, so I might fumble a little bit, but it's an interesting calculator to use, and it is really full-featured. If you haven't watched the initial video that shows how to set up the cross-country line and how to start to fill the parameters in the first lines, then I would suggest you look at that before you continue with this video. And then once you've done that, well, welcome back, and let's get on with it. The CR-3 has two sides to it, like an E6B. In this case, if you look at the slide rule side here, is set up so that the outside range here is used for miles and quantities like gallons or of fuel or things like that, and you can also do a variety of different conversions using it. The inside, or grayscale in this case, is used for time. So in this particular case, we're going to be using the other side first to figure out, what our true airspeed is and what our true heading is going to be. So we start off with putting our true airspeed. You can see here we're above the true airspeed mark, and our true course over our true course, which is 200 here. This inner scale here allows us very quickly to find if we know what our variation is, and in our case it's plus 14 degrees. That would tell me that my my magnetic course is 214. But that's not really what I want right now. What I really want is to calculate what our magnetic heading would be. In other words, the influence of wind and how much am I going to be, how much do I need to crab to correct for it. So the next step is we look up the wind, which is 300, and we go in on that scale until we get to 9 knots. And you can see here, I forgot to erase from my last attempt. You can see my actual little rectangle here, kind of rectangle, that shows when I did the rest of my calculations. So 3,309 brings me to this point here. I can project that onto this scale over here, and it gives me something like, if I were to kind of put it over here where I don't have this grommet here, it looks like a 6. So I have maybe 6 knots right crosswind, and if I go down here, I have maybe, pretty well the same thing, 6 knots tailwind. So right crosswind of 6 knots. When I look this up on this scale here, it's kind of outside scale, 6 here gives me a wind correction angle of around 3.5. I'm going to round that up to 4. So 200 plus 4 is 204. So that is my true heading, and I add 14 to that is 218. Compass heading, I don't know, I'll have to see the compass itself. So that essentially gives me my my wind correction angle. If I look at here, now I have, I said about 5 or 6 knots of tailwind. So if I add that to 105, it gives me 110. So that is my my ground speed. Now, does it make sense? I always want to do that. So I am flying a heading of about 200. My wind is coming from the northwest, So if I will need to turn more towards the north, so I will increase my number. So an increase of 4 degrees makes sense. And I've got a tailwind, so an increase of ground speed makes sense. So ground speed 110 makes sense, 204 true angle makes sense. So now we go to the other side. And here we're going to need to, as I've explained a little bit here, I want to get my 1 hour mark here under my ground speed. So 110. And then with that, I can figure out very quickly with my distance, what my time is going to be. So 75 statute miles, 41 minutes. And my fuel now, so what I need to do is the same thing. Now I need to move my 1 hour under 6.3, which is my fuel, and go to 41 minutes, and that gives me 4.3 gallons. And okay, so start with 40 gallons. I'm going to add my times here, so that's 51, and my distances is not that. I need this here, so that would be 5.5. So 40 gallons minus 1.1, 5.5, 1.1. So start taxi, takeoff. I usually use the same thing for circuit and landing, so it gives us a total of 7.7. 10% contingency 0.8, 30 minutes reserve, half of 6.3, so that's about 3.2, being conservative, slightly conservative, and that works out to 0.7 and 11.7. So 40 minus 11.7, I did this calculation not too long ago, is 28.3. And if I divide that by my fuel rate, in fact, I could do it with, I can do that. Let's see, if I know what my fuel rate is 66.3, and I've got 28 here, so I will go and look, 28.3, and that gives me 4.5 on the 4 scale here. So that was actually 250 minutes, so that's 4.5. So the last thing we need to do is go back to indicated airspeed. So this is slightly more tricky. So I want to use this scale down here to figure out what my density altitude is. And so our temperature, if you recall, was 12 degrees. So in this scale here, I'm going to use 10 degrees. And our pressure altitude is 4420. So that's pretty close to 10 degrees. This is 4, so about 4.5 and 10 degrees. So my density altitude is about 5,000. And so what I'm going to do is I'm going to look up my indicated airspeed, or calibrated airspeed is going to be on the inside scale compared to true airspeed. So what I need here is true airspeed, not ground speed. So true airspeed is 105, and I look down here, so 97.5. 97.5. Again, makes sense. I have a density altitude of 5,000. So my true airspeed is what it is, 105, but my indicated airspeed is going to be much less than that because the air is much less dense at higher altitude. So that's how we use a CR-3 to do these basic calculations. So thank you for watching, and you can watch the other 3 instruments to use if you happen to have a CR-3, but each one is a little bit different, and you learn, I think, every one something different when you watch these different videos. So the last video is going to look at how we do the flight portion. So well, you're welcome to watch that and certainly all of the others. So thank you for watching. Thank you for your comments.